Hi, I'm Alex Lamb, author of the Roboteer science fiction novels, and you are watching Secrets of the Universe, the magnificent, if obviously ill-conceived video series in which I attempt to unpick every single major science topic, moral topic, and every kind of topic besides in the course of a single series. Hooray! What do I like to talk to you about today? And the answer is I'd like to talk about complex systems. I tried making this video before and it was a catastrophic failure. I babble like a maniac, so I tried again and I failed again. So this is me coming back and having a go at the video I seemingly cannot make. I either get too excited or I ramble like a maniac. What are we going to do? What happens this time? Well, first question, what is a complex system? A complex system is a pattern that shows up in nature in which you get a large number of apparently relatively simple parts, simple components if you like, but when you put them together, they do something surprising. There's some kind of effect that shows up, some behavior that appears when all of these little units are in aggregate, which isn't there when we look at the components when they're on their own. So it's like the reductionist path that took us all the way through 20th century science suddenly is breaking down. We are seeing something like what scientists refer to as emergence, where we get these new artifacts showing up that are a function of collective action. Lovely. So what's an example of a complex system? Well, bees. Try bees. One bee on its own doesn't do terribly much exciting. It sits there being a bee. Two bees. Yeah, and the same sort of thing, not very much. You have 1 trillion bees, you have too many bees. The whole world is covered in bees, that's the wrong number. How about, in fact, a few thousand bees? Then you have a hive, it's able to collectively self-organize, and all of a sudden you have a community of entities that are capable of doing things like making rational collective decisions, which the human race struggles with. Or indeed, dancing, they're good at that. All different manner of different things. You get the idea. Behavior in aggregate, swarms, what have you. We do have human beings. We have other manifestations of complex systems. We have like traffic jams. Like a traffic jam is a complex system. You're driving in your car, and that's you. And then it's like two cars on the road. Everything's pretty normal. You put a lot of cars on the road, and then all of a sudden you get pulses and squidges and stop-and-go driving, and it gets steadily more annoying. But the point is that it shows all of these sort of interesting complex system dynamics. Pretty much any time you get a whole bunch of units, squidge them together, and something trippy happens. That's complex systems. Why is it interesting? Why do we care? Because you, ladies and gentlemen, are a complex system. I am a complex system. The society in which we live is a complex system. The money that flows around us and determines what we cannot afford this month. Complex system. The ground beneath your feet, earthquakes that shake, the storms above your head, all of it, complex systems. So that makes it pretty interesting, I think. By understanding complex systems at some level, you have a better grasp of the entire world around you. Wonderful, and this is one reason why I get tremendously excited by this particular topic. We'll come on, there are other reasons, which I will talk about later in the video. So that's why we should get interested, but how do we do it? How do we do complex systems research? What is that a thing? Well, I would propose that there are, broadly speaking, two things that happen in complex systems research, looking for patterns and parallels. So what is a pattern? A pattern is, if you like, a repeating trend that shows up in a particular complex system. So you look at your bees and you're like, they're doing that thing again, they're doing the swarmy thing. It's like that's a measurable artifact then, and we're going to look at swarming patterns. Or you can say, I am on the M6 just south of Birmingham in England. And it's like, here it is, a traffic jam again. And it's like, there's a repeatable phenomenon that we can track. So the idea is we're looking for patterns, and we can quantify those patterns, we can measure them, we start sciencing them. So that's exciting, and start looking at when and how they show up, and what are the circumstances in the system. And then the really exciting place is where you also get parallels. And what parallels are, I would propose, is where having identified one kind of a trend or one kind of a pattern that can show up in one system, you then are able to show that the same kind of shit happens in some completely different system. And then you've learned something about both of them, and you've learned something about symmetries of organization between different scales, and that's when it gets really interesting. So for instance, you might look at the organization of genes within a particular cell, or indeed any cell, and then compare that to the organization of political systems, and you know, politics and how societies and governments self-organize in different human societies. Wow, and then we can learn things about what's happening in politics, gosh. Or indeed, you might look at patterns that show up in social networks, you know, the sort popularized by, you know, the fact that everybody knows about it because social media networks. And anyway, you get the idea. Like the patterns of friendships that we have, and you might look at that and then draw a parallel between that and Planck length space-time, and the kind of models that we can build of how the universe works down to its smallest possible scales. So yes, I've worked on those two particular things myself, but those are just two examples, but there's a great number of these. It's fascinating when you start to see that the universe is arranged in a sort of a stack of interesting systems where there are these repeat occurrences. There are these things that show up on all of these different scales. So tremendously exciting. It's like with complex systems that you've suddenly been given the keys to the kingdom, if you like. You have the means to see through not just one phenomenon, not one scientific department, but all of them. They line up like some components of magic crystal, and you can see all the way down. It's like, here are the symmetries that drive all the things. I love that, but there's one other thing that I love even more about it, and that is complex systems is both mysterious and approachable. Complex systems is something we still barely understand, which is why I tend to get excited about it. And also, you can do it at home, kids. It's a kind of a science that like rewards the act of doing simple computer modeling. The frontier is really close. There's a load to understand, and often what you need in order to be able to track or model or test a phenomenon, test your understanding, is about a page and a half of software, just like a page and a half of JavaScript code. If you can build a bloody website with turtles wootling around on it, or you can build the simplest possible game, then you have the keys to understanding the universe already clutched in your hot hand. And that's the truly exciting, wonderful thing as far as I'm concerned. And furthermore, a lot of these models, they get better when they're simpler, because you're looking for repeat symmetries which are not specifically related to the particular setting in which they're used. So if you're, for instance, comparing genes with politics, you don't want something that's a whole bunch of extra detail about genes or a whole bunch of extra detail about politics. You want the minimum amount necessary. So what that means is the piece of code that actually encodes and represents the pattern common to both, if it successfully encodes the behavior that you see in both, you've discovered a thing. So that means that the phone in your pocket, ladies and gents, or the laptop on your desk, probably the kind of device that you're watching this video with, is a tool for doing ultimate earth science of a kind that really is like, it's the giant, big, democratized science of the 21st century. It's the opportunity for everyone to play Galileo. You don't have to spend a decade and a half trudging up an academic track to be able to get to the frontier of stuff. It's in your hand right now. And there are beautiful pop science books out there that will take you to that place. You can pick up, like, here's a nice one, The Social Atom by Mark Buchanan. A lovely thing. You can read that, you can look at the models in there, and you can say to yourself, can I build that? Can I build a game? Back the other day, could I do this? Could I test my understanding of the subject? Because we can all get involved. That's what's magnificent about the subject. That's why it's so special, and that's why I appear to have actually successfully done the video this time. Only an edit test will tell, ladies and gents, but that's it. That's a summation. That's what I'm excited about. That drives a large amount of my interest in doing these videos and has taken me a great distance in my personal pursuit of understanding all the things. So there we have it. Thank you very much for listening and watching. Next time, something else, probably completely different. But in the meantime, hooray for you, and yes.